Imagine being hundreds of miles away from home with no map, no compass, and no phone telling you which way to go. The landscape around you looks completely unfamiliar, and once the sun disappears, everything becomes dark. Yet ancient humans could still find their way. They looked up. The stars that seemed like random points of light were actually repeating patterns, and those patterns could tell them which direction they were facing, when seasons were changing, and when it was time to move. But how did humans learn to turn the night sky into something they could actually read? Today, getting lost is almost impossible. Your phone can show your exact location, tell you which direction to walk, and even guide you through places you have never seen before. Ancient humans had none of that. If they traveled far from home, there was no blue dot waiting to show them where they were. But they had something that was always above them: the night sky. At first, the stars probably looked like thousands of separate points of light scattered across darkness. But if you watched them night after night, something strange became clear. They did not move randomly. The same stars appeared in the same parts of the sky again and again, following patterns that could be remembered. That was incredibly useful. Imagine living thousands of years ago and walking across a wide open landscape after sunset. There are no roads, no signs, no streetlights. The hills you normally use as landmarks have disappeared into darkness. You might still know where home is, but only if you can find something that gives you direction. The stars could do that. Ancient humans were not born knowing how to use them. They had to learn through repeated observation. A person might notice that a certain group of stars appeared each night. Another might notice that the same group slowly shifted as the seasons changed. Over many generations, these observations became shared knowledge. The important part was not knowing the name of every star. It was recognizing a pattern. Once people could recognize a pattern, they could remember it. Once they could remember it, they could teach it to someone else. And once that knowledge was passed down for generations, the sky became more than something beautiful to look at. It became a reference point. This also explains why navigation was never as simple as just picking one bright star and following it. Skilled travelers combined what they saw in the sky with landmarks, the position of the sun, knowledge of the landscape, and memories of previous journeys. The stars were one part of a much larger system for finding the way. And there was another advantage. The sky did not disappear when humans moved into a new place. A river could change its course. A tree could fall. A familiar hill could look completely different from another direction. But the stars followed patterns that could be observed again and again. That made the night sky one of the most reliable reference systems available to people who traveled beyond familiar ground. But recognizing patterns was only the beginning, because eventually humans discovered that some stars were far more useful than others. One particular star seemed to hold almost still while the entire night sky appeared to turn around it. And once people learned what that star could tell them, the night sky became something much more powerful than a simple collection of lights. There was one problem with using the stars as a map. The stars moved across the sky. If you watched them for several hours, the whole sky seemed to slowly turn. A star that was above you earlier could be somewhere else later. So if ancient humans wanted to use the stars for direction, they needed something more reliable than simply finding the brightest star. In the northern sky, they had one of the best possible reference points. Polaris, the star we call the North Star, lies very close to the North Celestial Pole. Because of that, it appears to stay almost fixed in the northern sky, while the other stars seem to circle around it during the night. That does not mean Polaris is literally motionless. Earth is rotating, and Polaris itself is moving through space. But from the ground, its position makes it an extremely useful marker for north. For an ancient traveler, that was a huge advantage. If you could identify Polaris, you could identify north. And once you knew north, you had the other directions too. That fixed north. And east is on your right. West is on your left. South is behind you. No compass was needed. But there is an important detail here. Polaris was not always the North Star in the way we think of it today. Earth's axis slowly changes its direction over thousands of years, a process called axial precession. Because of this, the identity of the star closest to the North Celestial Pole changes over long periods of time. So when we say ancient people used the North Star, we have to be careful about which period and which culture we are talking about. The broader idea is much older than the modern name Polaris. Humans could identify stars near the celestial pole and use the northern sky as a stable reference. Different cultures developed their own ways of describing and using using what they saw. And this tells us something important about ancient navigation. They did not need to understand why the Earth was rotating. They did not need to know that Earth was a planet orbiting the sun. They only needed to notice a repeated pattern. That is one of the most fascinating parts of ancient knowledge. A person can use something accurately without understanding the physical laws behind it. A hunter did not need modern biology to know where animals gathered. A farmer did not need atmospheric science to notice seasonal changes. And a traveler did not need modern astronomy to understand that one part of the sky was a better direction marker than another. The knowledge came first, the explanation came much later. But Polaris had another limitation. It was useful mainly to people in the northern hemisphere, and it was not equally useful everywhere. The farther south you traveled, the lower it appeared above the horizon. Eventually, from the southern hemisphere, it disappeared completely. That meant ancient humans needed more than one trick. They needed to understand the sky as a whole. They had to know which stars appeared in which season, which patterns returned, and which parts of the sky could help them when one familiar reference point was no longer available. And this is where the stars became much more than a compass, because once people realized that the sky changed in a predictable way throughout the year, they discovered something even more valuable. The stars could tell them not only where they were going, but when they were in the year. Finding north was useful. But ancient humans soon discovered something even more powerful. The stars could tell them when they were. The night sky does not look exactly the same throughout the year. As Earth moves around the sun, different parts of the sky become visible at different times of the year. A star or group of stars that is easy to see during one season may disappear from the evening sky months later, only to return again at another time. For people who depended on seasonal changes, this was valuable information. They did not need to know that Earth was orbiting the sun to notice the pattern. They only needed to remember what the sky looked like when certain things happened on the ground. A particular group of stars might appear around the same period that a certain plant began to grow. Another might become visible around the time rains usually arrived. Somewhere else, the appearance of a star might mark a season when animals became easier to find or when people needed to prepare for colder weather. The stars became a kind of natural calendar, and this was not just a vague feeling. Some ancient cultures made careful observations of when celestial objects appeared or disappeared near the horizon. In ancient Egypt, for example, the annual reappearance of Sirius in the morning sky became associated with the approaching Nile flood. The timing was important because the Nile's flooding shaped farming life across Egypt. But there is an important detail. Ancient people were not simply looking at one star and predicting everything that would happen. They were connecting the sky to changes they had already observed on Earth. The same pattern repeated. The same season returned. The same stars appeared. The same environmental changes followed. After enough years, the connection became useful knowledge. This is where the stars became incredibly powerful. A person who could recognize seasonal patterns in the sky could help a community decide when to travel, when to prepare for certain weather, or when important seasonal activities were approaching. The sky was no longer just a direction finder. It was becoming a clock, and it was becoming a calendar. But there was still a problem. A sky full of thousands of stars is difficult to remember. If you wanted to teach someone else where a particular star was, simply saying, "Look over there," would not work. So humans did something remarkably simple. They connected stars together in their minds. They started seeing shapes. Groups of stars became recognizable patterns, and those patterns would eventually become some of the most famous constellations in human history. Once humans began recognizing patterns in the sky, something very human happened. They started giving those patterns meaning. A group of stars could be easier to remember if people imagined a shape connecting them. A hunter, an animal, a warrior, a tool, a creature from a story. The actual stars did not change. The pattern existed in the human mind, and this turned out to be incredibly useful. Imagine an elder teaching a child how to recognize an important group of stars. Instead of saying, "Remember those 5 points of light in that particular position," they could give the pattern a name and connect it to a familiar story. Now, the child had something to remember. This is one reason constellations became so important across different cultures. People living in very different parts of the world looked at the same sky, but they did not always see the same pictures. The stars stayed the same. The stories changed. Ancient Greek traditions gave names and stories to constellations that are still familiar today. Other cultures developed completely different star patterns and celestial traditions. In parts of Australia, indigenous peoples developed their own detailed ways of reading the night sky, including patterns based not only on the bright stars, but also on the dark spaces between them. That last detail is easy to miss. Humans did not only learn to recognize what was shining. They also learned to notice what was missing. Dark shapes in the Milky Way could form recognizable patterns against the brighter background. For some indigenous Australian traditions, these dark sky features were meaningful parts of the night sky. This shows just how sophisticated human observation could become. The night sky was not simply a collection of lights. It was a giant information system. But there is something even more interesting about constellations. The stars in a constellation usually have no physical connection to each other. They can be at very different distances from Earth. They only appear to form a shape because of the way we see them from our position in space. So when an ancient person saw a hunter or an animal in the stars, the shape was not actually floating out there in space. The pattern existed because a human mind connected the points, and that may have been one of our greatest advantages. Humans are extremely good at recognizing patterns. We do it with faces, tracks, sounds, seasons, and landscapes. The night sky gave us another enormous pattern to learn. Once a pattern had a name, a story, and a place in the culture, it became much easier to pass from one generation to another. A child could learn the stars from a parent. That child could become a traveler. Years later, they could teach the same pattern to their own children. The stars had now become more than navigation. They had become memory stored in the sky. But knowing the names of star patterns was only useful if people could remember exactly where those patterns appeared and how they changed throughout the year. And that raises an even bigger question. How did ancient humans keep all of this knowledge accurate without books, charts, or modern instruments? A modern astronomer can open a computer and instantly find the position of almost any star in the sky. Ancient humans had no such advantage. There were no printed star charts, no telescopes, no apps showing exactly where a constellation would appear tonight. So how did this knowledge survive? The answer was surprisingly human. They practiced. A person who spent years traveling, hunting, fishing, or living outdoors could see the same patterns hundreds or thousands of times. The sky was not something they studied once. It was something they lived under every night. The more often a pattern was observed, the easier it became to recognize. And people could teach those patterns through stories, songs, names, and repeated observation. This mattered because ancient knowledge did not have to be written down to be precise. A skilled navigator could remember a sequence of stars, the direction they appeared from, their position relative to the horizon, and the seasonal conditions connected to them. But memory alone was not enough. Ancient travelers also had to understand that the sky changes depending on where you are. A star that appears high above the horizon in one place may appear much lower somewhere else. Some stars visible in one region cannot be seen from another. The farther people traveled, the more important these differences became. This is one reason navigation was never just about memorizing a single star. It was about understanding relationships. Which stars rise together? Which ones disappear below the horizon? How high does a particular star appear? Which direction does a familiar pattern move during the night? What time of year does it appear? The answers to these questions created a mental map, and the most impressive examples came from people who traveled across enormous distances without modern navigation equipment. Polynesian navigators are one of the clearest examples. For generations, Pacific voyagers developed sophisticated systems for finding their way across huge stretches of ocean. They used stars, but stars were only part of the system. They also paid attention to the sun, winds, ocean swells, birds, clouds, and other signs of nearby islands. The ocean had no roads, there were no mountains to guide them once land disappeared below the horizon, yet experienced navigators could use the movement of celestial bodies and the behavior of the ocean to maintain a course. That tells us something important about what it means to read the stars. It did not mean staring upward and magically knowing where to go. It meant learning a system so deeply that individual observations became connected. The stars told you one thing. The waves told you another. The wind gave you another clue. And together, those clues could point toward a destination that you could not even see. That is a very different kind of knowledge from simply knowing the names of constellations. It was practical knowledge. Knowledge that could determine whether a journey succeeded or failed. But ocean navigation reveals something even more surprising. The stars did not have to be bright or dramatic to be useful. Sometimes the most important clue was a star that appeared in exactly the right place at exactly the right time. And that brings us to one of the most remarkable ways ancient humans learned to turn the sky into a navigation system. There is a big difference between knowing that a star exists and knowing how to use it. Ancient humans eventually learned that some stars were useful because of where they appeared in the sky. If a particular star rose from a certain part of the horizon, it could give a traveler a reference for direction. If another appeared at a different angle, it could help confirm that direction. The sky could be treated almost like a giant compass, but one that changed depending on where you were standing. This became especially important when familiar landmarks disappeared. On land, a traveler could use mountains, rivers, trees, coastlines, and other features to stay oriented. But once someone moved into a wide desert, crossed open grassland, or sailed far from shore, those landmarks could become useless. The horizon could look almost identical in every direction. The stars did not have that problem. A skilled traveler could recognize a familiar pattern and use its position to keep moving in the right direction. They could also use the changing position of stars during the night to understand how much time had passed. Navigation was becoming a combination of direction and timing. But there was another trick. Ancient navigators could pay attention to where stars appeared to rise and set along the horizon. Different stars followed different paths across the sky, and their positions could provide clues about direction. The exact method depended on the culture, location, and journey, but the basic principle was simple. Learn the sky well enough, and the movement of the stars becomes information. This was especially valuable for people who traveled across water. At sea, there are very few fixed landmarks. An island can disappear below the horizon, and another island may be impossible to see until you are relatively close to it. A navigator could not simply point at a mountain and say, "That way." Instead, they had to build a mental picture of where they were going. Polynesian navigators developed some of the most sophisticated traditional systems of ocean wayfinding ever documented. Their knowledge included star paths, ocean swells, winds, birds, clouds, and other environmental signals. The stars were not a single magical solution. They were one part of a much larger system that worked together. This is an important distinction. Ancient navigation was not about finding one perfect star and following it forever. It was about constantly checking your surroundings. If the stars suggested one direction, but the waves and wind suggested something unusual, the navigator had more information to consider. If a familiar bird appeared, it could provide another clue about nearby land. If clouds formed in a particular way over the horizon, they could hint at islands beyond what the eye could see. The more knowledge a navigator had, the more pieces of the puzzle they could connect. And this explains why experienced navigators were so valuable to their communities. Their knowledge could not simply be replaced by looking at the sky for a few minutes. It came from years of practice and observation. They had learned the behavior of the stars so deeply that the night sky became almost like a familiar landscape. But there was one major problem. What happens when the sky is covered by clouds? The stars disappear, and suddenly the most reliable map ancient humans had ever created was gone. That is when we discover that they had never depended on the stars alone. For all its power, the night sky had one obvious weakness. Sometimes you could not see it. Clouds could cover the stars. Smoke could fill the air. Rain could turn the entire sky into darkness. Even a bright moon could make some stars much harder to see. For an ancient traveler, that could be a serious problem. But this is where we need to correct another common idea about ancient navigation. They were not completely helpless whenever the stars disappeared. The stars were one part of a much larger system of environmental knowledge. During the day, the sun could provide direction. On familiar journeys, people could use mountains, rivers, coastlines, valleys, and other landmarks. Experienced travelers could also remember the shape of the landscape and the position of important features along a route. On the ocean, the situation was different. But even there, the sky was not the only source of information. Polynesian navigators, for example, developed knowledge of ocean swells and wind patterns alongside their knowledge of stars. Waves could travel long distances across the Pacific and interact with islands in ways that experienced navigators could recognize. Clouds could also provide clues because islands can affect the clouds and weather around them. Birds were another useful signal. Some seabirds travel away from land to feed and then return toward their nesting areas. Seeing certain birds in the right conditions could suggest that land was not impossibly far away. A navigator who understood these patterns could combine them with everything else they were observing. This is what makes ancient navigation so impressive. It was not one trick. It was a system of overlapping clues. If one source of information disappeared, another could still help. The stars might tell you your direction, the waves could confirm your course, the wind could tell you how the environment was changing, birds could suggest nearby land, and memory could tell you what should appear next. The best navigators were constantly comparing these signals instead of blindly trusting a single one. That also explains why ancient navigation could take years to master. You could not learn every part of it from one short lesson. You needed to experience different seasons, different weather, different sea conditions, and different parts of the landscape. You had to make mistakes. You had to notice what you missed, and then you had to remember those mistakes. Over time, the natural world became a kind of classroom. The most interesting part is that modern technology has not made these ancient skills completely irrelevant. Even today, professional navigation systems are designed around the same basic goal: determine where you are, determine where you need to go, and constantly compare new information with your expected position. The difference is that our instruments can perform measurements far beyond what human senses can detect. Ancient navigators had to build that understanding inside their own minds. And perhaps that is why the next step in this story is so important. Humans did not just learn where the stars were. They began asking a much bigger question. Could the stars tell us what time of year it was, where we were on Earth, and what was coming next? By this point, ancient humans had learned something remarkable. The stars were not just lights above them. They formed patterns that could be remembered, compared, and connected to changes happening on Earth. A certain pattern might appear in the evening sky around the same season every year. Another might become visible before an important change in weather or the landscape. Over many generations, people could connect those celestial patterns with events they depended on for survival. This was especially useful for people whose lives followed strong seasonal cycles. A community might need to know when rains were approaching, when temperatures would begin to fall, or when certain plants and animals would become available. The sky could provide a reference for these changes because its patterns repeated with remarkable regularity. The important word here is repeat. Ancient humans did not need to understand the physics behind the stars to notice that the same celestial patterns kept returning. If something appeared year after year around the same part of the seasonal cycle, it became useful information. This is one reason some ancient cultures paid close attention to the first appearance of particular stars near the horizon just before sunrise. These observations could become important seasonal markers. Ancient Egypt provides one of the clearest examples. The star Sirius was associated with the annual flooding of the Nile, and its heliacal rising became an important event in the Egyptian calendar. The timing was not a magical prediction of the future. It was an observed relationship between the sky and a major seasonal event. That distinction matters. Ancient people were not looking at stars and seeing secret messages about everything that would happen. They were noticing that nature repeated itself. The stars returned. The seasons returned, the river rose. Plants grew, animals moved, and humans learned to connect these events. Over time, this knowledge became so useful that people began building calendars to organize it. This was a huge change. Instead of simply remembering that a certain star appeared before a certain season, communities could begin organizing activities around predictable cycles. The sky became a reference for time itself, and once humans could track time, they could do something even more powerful. They could plan. A journey could be timed according to seasonal conditions. Farming activities could be organized around expected changes in weather. Ceremonies and gatherings could be connected to particular times of the year. The stars were no longer just helping humans survive one night at a time. They were helping humans organize life across entire seasons. But there was still a limit. Knowing that a star would appear every year was useful, but humans wanted something even more precise. They wanted to measure the sky, compare positions, and record what they were seeing. That is when watching the stars began to turn into something much closer to astronomy. And surprisingly, some of the earliest people to do this were not simply wandering hunters staring into the night. They were building settlements, keeping track of seasons, and creating societies large enough that the sky itself became part of how they organized their world. At some point, simply watching the stars was no longer enough. Humans wanted to know exactly where things appeared, when they appeared, and how those positions changed over time. That was a major step. Instead of treating the sky as something to observe, people began treating it as something that could be measured. One of the best-known examples comes from ancient Mesopotamia. Babylonian astronomers made long-term observations of the sun, moon, planets, and stars. Their records became detailed enough that they could identify repeating patterns in celestial movements and use those patterns to make predictions about where certain objects would appear. They were not using modern telescopes. They were observing the sky with the naked eye and recording what they saw. This required patience on a scale that is difficult to imagine today. A single night could tell you very little, a year could tell you more. But observations collected across generations could reveal patterns that one person would never notice alone. That is the real power of ancient astronomy. Knowledge accumulated, one generation observed the sky and passed information to the next. The next generation added more observations. Eventually, people had records covering long periods of time. The sky became something that could be compared with the past. If a planet appeared in a certain part of the sky, Ancient observers could compare it with earlier observations. If a celestial event happened again, they could look back and search for previous examples. This was a completely different level of understanding from simply knowing that stars existed. And it shows why writing became so important. Once observations could be recorded, they no longer depended entirely on human memory. A person could die, but their observations could remain. Someone born generations later could study what an earlier observer had seen. That created something humans had never had before, a memory of the sky that could outlive the people who created it. But there is an even bigger reason this mattered. Ancient humans were not only trying to understand the stars because they were curious. Celestial observations could help organize calendars, support navigation, and track the movements of the sun, moon, and planets. The sky had become part of everyday life. And slowly, humans began to realize something that would change how they understood their place in the world. The stars were not just telling them where to go. They were showing them that the universe itself followed patterns. And once humans learned that the sky could be measured and predicted, the question changed completely. It was no longer just, how do we read the stars? It became, how much of the sky can we actually understand? Ancient humans turned the night sky into a map, a calendar, and a guide for survival. They learned its patterns, remembered them, and passed that knowledge to the next generation. Today, we have GPS and digital maps, but we are still reading the same sky our ancestors once depended on. They looked up because they needed to find their way. We look up because we still want to understand where we are. If you enjoyed this journey into the world of ancient humans, subscribe for more stories that reveal how our ancestors survived, explored, and understood the world around them.